Hello class, sorry I can't be here today, but go ahead and take your notebooks out and we will do a little short lesson today via video. In your notebooks in the top right corner, I want you to put a few things. I want you to put our unit. Our unit is exponents. And then, specifically in exponents, we are studying multiplying and dividing. And this is something that we covered a little bit at the end of last year. So, but this is where we're going to be touching on at the beginning of the year. So first let's talk about what an exponent means. An exponent is just repeated multiplication. Much like how multiplying is repeated addition. So like if I have 2 to the 5th, that's the same as saying that you're multiplying 2 5 times, which is 2 times 2 is 4. 4 times 2 is 8, times another 2 is 16, times another 2 is 32. Remember, you can multiply, or you can write multiplication with the x, but we usually don't do that. You can multiply, you can write it with dots, or you can write it with parentheses like this. Our main focus today is going to be dealing with multiplying an exponent. So for example, if I have x squared multiplied by x to the 5th, how could I represent that? By kind of combining the two x's together. Well, if you think about it, so again, go ahead and write this down in your notes so that way you kind of understand the concept that we're trying to grasp. This is x squared, which is x times x, and then x to the 5th is x times x times x times x times x. You want to be able to write this as one exponent. So you have two x's, 1, 2, and then 5 more x's, 3, 4, 5, 6, 7. So that makes x to the 7th power. Let's look at another situation. What if I had, write this one down too, just 1x multiplied by x to the 4th multiplied by x to the 3rd. How could I simplify that? So this 1x is just still 1x, and then I have 4 x's. So 1, 2, 3, 4. And then 3 x's, so 1, 2, 3. How many x's do I have altogether? How many x's total are being multiplied? We got 1 from the first set, 2, 3, 4, 5 from the second set, 6, 7, 8 from the third set. So x to the 8th. Now remember, you don't necessarily have to write the x's every time. You can kind of count. You have 1 and 4 more make 1, 2, 3, 4, 5. And then 3 more than 5 is 6, 7, 8. But certainly, if writing it all out helps you, then you should probably do it that way. So that's multiplying. The title today was multiplying and dividing. So what if I have x to the 5th divided by x to the 3rd? Well, what am I going for there? So typically when you divide numbers, they get smaller. There are some special cases when they don't. But generally, we're going to end up with less x's than when we started, when we are multiplying when we are dividing x's. So I have 5 x's on the top of the fraction and 3 x's on the bottom. If I have an x on top, it will cancel out the x on the bottom. So notice 3 of the 5 x's on the top canceled out. So this is x, and then 2, so x squared. What if it was flip-flopped? What if it was x to the third over x to the fifth, this time in the bottom? If you guessed that the answer was the same, you're close. It's almost the same. So we have 3x's being multiplied on the top and 5x's being multiplied on the bottom. 3x's still cancel out of the total 5 on the bottom, and you're still left with 2, but this time they're left on the bottom, so you're left with a fraction, 1 over x squared. You put a 1 on top. This might be a note to make to yourself. You put a 1 on top as a placeholder. Because you can't just have a fraction with nothing on the top. So you put a 1 there. So it's not just kind of floating off into the universe. So now let's rock your brain a little bit. What if I have like multiple variables in the same problem? So if I have like x to the third, y squared multiplied by x and y to the fourth. This might seem scary because you have x's and y's in the same problem, but it's actually quite simple. Since this is all being multiplied, x is being multiplied by y, and that is then being multiplied by another x and another y, it doesn't really matter the order in which you do things. So you can kind of group the things that you need together. So if you focus on the x's first, you have 1, 2, 3 x's here, and 1 x there, for a total of 1, 2, 3, 4 x's. So your final power of x is x to the fourth. And now you can focus on the y's. We've got 2 y's here, and then 4 y's there. So 2 y's multiplied by 1, 2, 3, 4 y's. So that gives us 3, 4, 5, 6 y's altogether. Again, if you're starting to understand the pattern, that's great. You don't necessarily have to write out all these x's and y's every single time. I write it down here to kind of help you out. Let's do another one. How about, let's make it a little bit more challenging and put some coefficients in here. So we have 2x squared times y multiplied by 3x to the fifth y to the third. Now, here's what people tend to get a little tricked. The x's are still going to go together, and the y's are still going to go together. But it's the 2 and the 3 that you really need to pay attention to. This is all still being multiplied. So this is technically 2 multiplied by 3. Again, remember, parentheses mean multiply. So this is just a big giant group of multiplication. So the 2 and the 3 get multiplied together, so that's 2 times 3, which is 6. And then, let's focus on our x's. We've got 2 x's here being multiplied, and then 5 x's over here. So 1, 2, 3, 4, 5, 6, 7. So x to the 7th. And then for our y's, we've just got 1 y in the first group, and then 3, 1, 2, 3 in the second group. So 1, 2, 3, 4, y to the fourth. I bring up an example like this because it's very common for people to mess this up and get confused by the 2 and the 3. It might be your instinct, since it's kind of like you're adding the powers of the x's and the powers of the y. A lot of times people want to add 2 plus 3 and say that that number should be 5. That would be incorrect. Let's work on some more dividing, and then I will give you the rest of the time to work on your assignment. So if I have like x's and y's and they're being divided, so how about x squared y to the 5th over x y to the 7th. Just like the example we did up here, we have to think about the fact that we have x's on top and bottom. This time we just have x's and y's, so we think about it in 2 separate parts. So focusing on the x's here, I have x and x over just 1x. So those x's cancel. My final fraction will have 1x in it. That x will be on the top because that's where the leftover x's are. I have 2 x's on the top and 1x on the bottom, so I'm left with 1x altogether. Now for the y's, 1, 2, 3, 4, 5 y's, and then 1, 2, 3, 4, 5, 6, 7 y's. Let's do some canceling. 1, 2, 3, 4, 5. So 5 y's disappeared, and we're able to cancel out. All 5 of these y's canceled out almost all of those 7. I've got 2 left over. Those 2 y's left over are in the bottom, so you have 1x on top and 2 y's on the bottom. And that's your answer. Let's approach it with some numbers in there as well, some large numbers. So looking here, we have 10 and 20 first. Now those numbers are being divided. And so you can think about 20 divided by 10, and that's 2. But think about where your larger number is. Again, you're dividing here. You're not like subtracting or anything like that. It feels like we're subtracting up here in this example, but technically you're dividing. So 10 divided by 20, that would end up being 1/2. So you can write the 1 on the top. You don't have to. I will for this example. But it's perfectly correct to write it without the 1. So now let's think about the a's. And just for example's sake, it doesn't really matter what order the a's and b's are. So I could have written it like this. And my process is still the a's. They're still the same. I have 1 a on the top and 2 a's on the bottom. And so 1a from the top can cancel out 1a from the bottom, and you're left with 1a on the bottom. Now let's look at the b's. You have 1b on the top and 3 b's on the bottom. So this 1b is canceling out that 1b, and you're left with 2 b's, again still on the bottom. So that would be your solution. And again, you don't necessarily have to write this process down here out if you don't want to, if it helps you. Ideally, you'll get really good at these to the point where you'll be able to do them in your head, but you just might not be there yet. One last thing, if you have a situation like this, like 3ab over 2ab, this a cancels out that a, and that b cancels out that b. Totally, there's no powers, so there's no more letters left. There's no more variables. It's just 3 over 2. That happens often. Thank you for your time. Now, get the worksheet from the sub and work on your assignment. We'll go over questions tomorrow.